So Math 30-1, we are now working on sum and difference identities, and we're just trying to build our toolbox. And in this section, the learning target is to look and see at things like sine of A plus B, the sine of sum of angles or the sine of a difference of angles. What does that translate to? You can recall our unit circle and those values we're going to use in a second. So in this statement, it's saying, geez whiz, I wonder if I can just distribute this sign, and I wonder if this statement here is true. Determine whether that's true or not. So plug in the values of 60 and 30. So is the sign of, in this case, 60 plus 30 equal to the sine of 60 plus the sine of 30? Let's try and see if we can work that out. So as you go through, it says verify that with 60 and 30 and see what each of those is equal to and see if the left side equals right side. So clearly when you look at the sine of 60 plus 30 is just the sine of 90. Well, the sine of 90 degrees is clearly 1. The sine of 60 is root 3 over 2 plus a half, so the right side is equal to root 3 plus 1 over 2. Therefore, we can clearly see that the left side does not equal the right side. Use exact value. Use the exact values to verify the following statements. Well, clearly we already know if we want to verify this right side we know needs to be 1. Well, let's look and see what this right side is and verify that. So this is root 3 over 2. Cosine of 30 is root 3 over 2. The cosine of 60 degrees is a half, and the sine of 30 degrees is a half. This side equals 3 over 4 plus 1 over 4, which equals 1, and therefore left side equals right side. So this statement is true. Well, let's look and see what sine of pi over 3 minus pi over 6. Well, I guess we can go through that, but in this case it's just radians. It's very much the same as the other one. This right now, sine of pi over 3 minus pi over 6. So in terms of the left side, this is the sine of pi over 6, and that's the sine of 30 degrees, and so that's a half. What do we get when we have a difference of angles here? So we have the sine of pi over 3, that's the sine of 60, so that's root 3 over 2. The cosine of pi over 6 is root 3 over 2, minus the cosine of the cosine of pi over 3 is 1/2, and the sine of pi over 6 is 1/2. So we end up with 3/4 minus 1/4, which is equal to 1/2. Left side equals right side, and this is true. So that statement is true. Cosine of 30 degrees plus 60 degrees, again, we'll try that out. Seems like an awfully silly thing to write, but let's see if it is. Well, clearly on this side, the cosine of 90 degrees, well, cosine at 90 is equal to 0. What is this whole long statement equal to? Well, cos of 30 is root 3 over 2. The cos of 60 is 1/2 minus the sine of 30, which is 1/2, and the sine of 60 is root 3 over 2. We end up with root 3 over 4 minus root 3 over 4, which is clearly equal to 0. Left side equals right side. So that's true. Seems like we've got some kind of rule going on here. What if we had the cosine of a difference of angles? Well, clearly it'd be much easier to just say, okay, well that's easy. That's just the cosine of pi over 4. And we know what that's equal to. That's 1 over root 2. What do we get when we do all this work? Well, the cosine of pi over 2 is 0. So I know we can do the cosine of pi over 4, but that doesn't really matter because you're multiplying by 0. But this is 1 over root 2, so it's 0 plus the sine of pi over 2 is 1, and the sine of pi over 4 is 1 over root 2. So we end up with this equal to 1 over root 2. So left side equals right side. And now we need to look and see, what does this really tell us about the cosine or sine of differences of angles? When we look at the next page, we have a list of identities. We haven't proved anything, but we've proved them for 30s and 60s. And this now is our, I suppose this now is our tools. We can now add these tools right here to our repertoire. We don't have to memorize those things. And if you go to this page here, you can look up and see the proof. There are other things. There is a tangent sum. So what happens if you take the tangent? Well, clearly we know this won't work. The tangent of A plus B is not equal to the tangent of A plus the tangent of B. You can't just distribute tangent and think that's going to work. They have two new rules right here that says, okay, well, the tangent of A plus B is equal to that. And therefore, if we divide the numerator and denominator, we end up with a simplified version. What about tangent of A minus B? Using the same procedure that you just looked at right here, can you guys go and come up with a new identity for tangent of A minus B? So use what you learned in these two things and come up with that, okay? So clearly we know that the tangent A minus B is equal to sine over cos. And then if we use our sine and cos difference identities, we end up with sine A minus B is equal to sine A cosine B minus cosine A sine B. But the cosine difference identity works a little different. It ends up being cos plus sine sine. I should have had it AB, but I didn't. Okay, and so now you have to ponder, well, how can I simplify that expression? So what the trick suggested in the previous example was, what if you took that cosine sum identity and sine sum identity, and what if you divided both the numbers by cos A and cos B? What would happen? Can we use that same strategy here to take what we've got to here and try and make this simpler? And that's the plan that we need to try and follow through with. So what are we going to divide? Well, if we divide our whole expression and divide the top by cos A and cos B, and divide the total denominator by cos A and cos B, that green expression that we hopefully make sense of becomes something simpler. And what do we end up when we divide both of those in there? What do we end up with? Well, in the first term, we end up with the cos b's cancel out, so you get sine A over cos A, which is tangent A, minus the cos A's cancel in the next one, so you get tangent A minus sine B over cos B, which would be minus tangent B. And on the bottom, we end up with 1 plus tangent A tangent B. And there's our new identity right there, and that's where it came from. It's not just magic, it actually comes from the work we do with rational expressions, and the tools that we learn build new tools, okay? Moving on to other examples. Express 15 degrees as two positive angles and determine the exact value of sine 15 with a rational denominator. So use the skills we've learned. We don't know the exact value of 15 degrees, but we do know that we can express that in many ways. What angles do I know? Well, I do know that 60 minus 45 degrees would definitely be 15. So now I just simply use my sine identity and I follow through with 60 minus 45. So this would be the sine of 60 cosine 45 minus the cosine of 60 times the sine of 45. We follow through and we get root 3 over 2 times 1 over root 2 minus minus 1/2 times 1 over root 2. So we end up with this equal to root 3 minus 1 all over 2 root 2. But the question said with a rational denominator, so I need to multiply the top and bottom by root 2, and that will give me the square root of 6 minus root 2 all over 4. Now there you have the exact value of the sine of 15 degrees. 5 pi over 2, I think it says express as a sum of two special angles and hence show that this statement here is true. One of the things that we can do is, just as always, 5 pi over 12 may not be something that you guys really enjoy, so it's perfectly fine to just work in degrees. So you could change 5 pi over 12 automatically. That's 5 times 15 degrees, which ends up being 75 degrees. So if somebody wants the cotangent of 75 degrees, it makes sense just to call that the cotangent of 75 degrees, which is equal to 1 over the tangent of 75 degrees. So why don't we just find the tangent of 75 degrees and then take the reciprocal.